There's a strange moment that happens when you're doing something difficult. Maybe you're halfway through a workout. Maybe you're staring at a problem you still haven't solved. Maybe you've been working on the same project for hours. Physically, you could probably keep going, but suddenly, you don't want to. Something inside you seems to decide, that's enough. Most of us blame that moment on willpower. We tell ourselves we weren't disciplined enough. We gave up too easily. But scientists have found something fascinating. Deep inside the brain are cells that appear to help decide how much effort is still worth spending for a reward. And when researchers changed the activity of those cells, they changed how long animals kept trying. The cells are called orexin neurons. They sit inside a tiny region deep in the brain called the hypothalamus. Think of the hypothalamus as one of your body's control rooms. It helps regulate hunger, sleep, body temperature, and other basic survival functions. Orexin neurons were already famous for helping control wakefulness, but researchers at Nagoya University in Japan wanted to know something different. What happens to these neurons when effort keeps getting harder? So they designed a simple experiment with rats. The rules were easy: touch a target, get food, but after every reward the price went up. The rat had to work more, then even more, for exactly the same reward. Eventually, every rat reached a point where it simply stopped. Scientists call that point the break point. In simple terms, it's the moment when the animal seems to decide, this reward is no longer worth this much effort. And this is where things became interesting. Researchers activated the rats' orexin neurons for a longer period. The rats kept working. Their breakpoint moved higher. They were willing to put in more effort before stopping. Then researchers did the opposite. When orexin neurons were greatly reduced, the animals gave up sooner. The reward hadn't become smaller. The food hadn't changed. What changed was the brain circuit involved in sustaining the pursuit. But that still left a huge question. What were these neurons actually doing while the rat was deciding whether to continue? So researchers watched them in real time, and what they saw was even more interesting. As the rat expected a reward, orexin activity increased. Then the reward arrived, and the activity dropped, almost like the brain had completed the task. But sometimes researchers delayed the expected reward. Now something different happened. The orexin activity stayed high, the reward hadn't arrived, but the circuit didn't immediately give up, and as getting the reward required more effort, the activity became stronger. That suggests these neurons may be doing much more than simply making an animal motivated. They seem to be connected to the relationship between effort, expectation, and reward. But now comes the twist. If activating these neurons for longer made rats persist, you might think scientists had discovered a motivation button. Just turn the neurons on, and suddenly you never quit. So researchers tried something more precise. Using light, they briefly activated the orexin neurons at the exact moment the rats were expecting a reward. The neurons responded, but the rats did not suddenly work harder. That short burst wasn't enough, and that changes the story completely. Motivation is not a simple switch. There isn't one button hidden in your brain labeled, keep going. The timing matters, the duration matters, the natural pattern of activity matters. And these neurons are only one part of a much larger brain system researchers are still trying to understand. There's another important limit. These experiments were done in rats. They do not prove that human brains work in exactly the same way. And they definitely don't mean scientists have found a magic way to make people more motivated. But the research reveals something important. Persistence may not be only about personality. It has biology behind it too. Your brain is constantly receiving information about what you expect, what you're getting, and how much effort something is costing you. So think again about that moment when you quit, that last rep, that unfinished page, that project you closed because suddenly, continuing felt pointless. Maybe your brain wasn't simply asking, can I keep going? It may also have been asking something much more important. Is this still worth it? And those are two completely different questions, because sometimes the moment you stop isn't the moment your body becomes unable to continue. It's the moment the calculation changes, and somewhere deep inside the brain, orexin neurons may be helping with that calculation. So the next time your brain tells you to quit, don't just ask whether you're tired. Ask yourself, did I actually reach my limit? Or did the reward simply stop feeling worth the effort? Because understanding that difference might completely change the way you think about motivation. Subscribe to FactBound for more science hiding inside the things you do every day.